Wetlands are the natural areas where land meets the water. A land that is wet for some period of time, but not always wet. Wetlands include the marshes, swamps, bogs and fens at the edges of lakes, rivers, bays, or low-lying areas that frequently flood.
Nature and natural areas can provide sort of productive services to the environment, and those might be habitat for fish, nursery, they can be carbon sequestration, it can be flood protection services if it's going to mitigate the flood. And so we use that term ecosystem service or environmental service to just denote that they are sort of capital investments in a way, a valuable service that they provide in the same way that physical capital provides a flow of services to the economy. So it's a kind of putting a little bit of an economic term on, a natural phenomenon.
The marshes for us as kids, we just had a good time. We used to ice skate in them when they used to freeze back in the day. And we would actually go down and ice skate on them.
The wetland provides benefits that are public in nature that are much more difficult to quantify, but we recognize that those benefits are there. It's sort of a natural thing we all kind of know. We all know that the water runs off the pavement and sinks into the forest or the wetlands. So, it's intuitive. The real question is how much it does that and what's the quantitative impact.
Researchers from the Flood Hazard Lab at George Mason University are working on understanding the physical interaction between marsh vegetation, storm surge, and waves.
We're looking into obviously having less flooding, which means lower water levels at some point. We're also thinking about having less wave energy as it propagates through the land.
Wave height attenuation means that when the waves are propagating through the vegetation field, the actual height of the waves decrease because the interaction of the waves seagrass.
So far we've looked into vegetation height, the diameter of the plants, and the density of these plants. And they all play a role, and we now have models that can correlate those vegetation characteristics to the amount of wave height attenuation that you will get over a given length.
A cross section of Magdi Bay, and we're doing right here is the difference between vegetation and no vegetation next 3 days. So if you can see, when it goes back up, the waves will attenuate in the vegetational areas but not in the non-vegetation areas.
This is just for measuring overall water levels, this Hobo water level log right here. This takes a water pressure reading, and from that water pressure reading we are able to determine depth of the water. We put them out in columns in the marsh, and we see how much the water levels can be attenuated by vegetation at the marsh. So we tried to record weather events as well. I can't bring the stuff in right now because it's currently out in the field, which is a good thing. It's taking data.
I'm a surfer, and I've been a surfer since a very young age. And I've been searching storms for very different reasons, but as a surfer you're really looking at the weather patterns because they're generating the waves. So I've been following storms and waves almost throughout my life.
I've accounted for probably like 3 or 4 different times where we've been trapped in our house for a week with no power because of the flooding.
We have increasing flooding, we have increasing problems with climate change and sea level rise.
We used to always go to Snyder's. All around it, they kept it marsh except for this one little place. And every time, for every storm, it flooded.
Figuring out the question of where people should live, how you can encourage them not to live in risky areas, how you can protect lands to protect people, are all sort of hard problems to deal with.
They rebuilt. I don't know how many times they rebuilt that restaurant, and they finally, it was just a few years ago, they got flooded again and finally said, we're done. We can't stay here.
Well, it is a challenge in general to value ecosystem services, to put dollar values on them. In the case of flood protection, the real value is the avoided damages to the property. So if you know something about how much flooding you're going to get, how much flooding you're going to avoid getting by having the wetlands there, you can calculate an avoided damage number. And that's what we've done in our research. Very sophisticated storm surge modeling is done to get a view of what the flooding would be with and without the wetlands, and you can do that in your numerical model methods. And we have property values at a very high spatial resolution, and we look at the differences in the flooding. We use some depth damage functions available from FEMA that are very specific, and calculate the dollar avoided damages. Hurricane Isabel was in 2003, and we estimated that the wetlands saved the state of Maryland about $450 million in damages. So if they hadn't had the wetlands that they have, flooding would have been worse, damages would have been worse.